All right, so if you've ever gotten your hands dirty with Cisco ACI, you know that one of the most common things you have to do can also be one of the trickiest, and that's inserting services. Things like firewalls or load balancers right into your traffic flow. If you get it wrong, your whole application can just grind to a halt. So today, we're going to break down the two main ways to get this done: the classic kind of manual method versus the new school automated power of service graphs. Let's dive in. First things first, let's set the stage. In pretty much any modern app, traffic doesn't just go straight from a client to a server. No way. It has to pass through what we call stateful service appliances. These are the brains of the operation, devices like load balancers or firewalls that are actually tracking the status of every single connection. The big challenge, the puzzle we have to solve, is how do we intelligently redirect or stitch that traffic path inside a really sophisticated fabric like ACI? Okay, so take a look at this. This is your classic scenario, right? At the top, you've got your basic ACI building blocks. EPGs are endpoint groups, sitting inside bridge domains, and it's all in one VRF for routing. Now, our mission, should we choose to accept it, is to get a client VM in one EPG to talk to a server VM in another. But here's the twist. It can't be direct. The traffic has to hit a virtual IP or VIP on that load balancer first. Then the load balancer works its magic, performs a source SNAT or SNAT, and forwards the traffic along. The question is, how do we actually build this flow? Let's start with method number 1, doing it all by hand without a service graph. Now, in this approach, we're basically treating our service device, the load balancer, as just another endpoint plugged into the fabric. ACI has absolutely no special clue that it's doing any kind of fancy service. To ACI, it just looks like any other external Layer 2 or Layer 3 connection. So what does that actually mean in practice? Well, it means you, the administrator, are responsible for stitching every little piece together. ACI isn't going to hold your hand and automate the policy. You have to get in there and manually define all the security rules, the contracts, for the traffic going into the load balancer and for all the traffic coming back out of it. And this diagram, this right here, illustrates the core of why this is the manual method. You see, because that load balancer changes the source IP address with a SNAT, ACI sees two completely separate conversations. It has no idea they're related. And that means you need two totally distinct contracts. The first one lets the client EPG talk to the load balancer's VIP. Then you need a second, completely separate contract to allow that brand new SNATed IP address to talk to the server EPG. Let's really trace that flow step by step. First, the client kicks things off, tries to connect to the VIP. Contract 1 checks its policy and gives it the green light, says, yep, you're good, and the traffic flows. Then the load balancer does its job and bam, it changes the source IP. But now, from the ACI Fabric's perspective, this is brand new traffic from a source it's never seen before. So it hits our second policy checkpoint where contract 2 has to be there, waiting to explicitly permit traffic from that new SNAT address to the final server. So here's the real kicker. You are totally on the hook for managing all of these in-between steps. You have to know exactly how the traffic is being transformed on that device, and then go and manually create all the policies to account for it. Now, it works, but wow, it creates a ton of administrative overhead and leaves the door wide open for misconfigurations. Okay, enough of the hard way. Let's pivot and talk about the modern solution, the one that was designed to solve this exact problem. The ACI L4 to L7 service graph. This is ACI's built-in, intent-based framework for automating the whole shebang. Now this slide, this is where the magic really happens. It perfectly captures the power of abstraction. That top diagram, that's your simple intent. You're just saying, hey, I want the client EPG to talk to the server EPG, and it needs to go through a service. You define one single logical contract. Then, ACI's service graph takes that simple instruction, and as you can see in the bottom diagram, it automatically builds and deploys all the complex stuff underneath. The two separate contracts, the correct traffic redirection, all of it, without you having to lift a finger. And this quote from the source material just nails it. The whole goal is to elevate your thinking. Instead of getting bogged down in the nitty-gritty network plumbing of VIPs and SNAT IPs, you get to focus on what actually matters, the application policy. You just define what should be allowed to talk to what, and you let the fabric figure out the how. Okay, so we've seen both methods in action. Let's put them side by side, do a direct comparison, and really highlight the differences. You'll see pretty quickly why this automation is such a game changer. This table really makes it crystal clear, doesn't it? Without a service graph, your focus is stuck on those intermediate network hops.
With a service graph, it's all about the end-to-end application policy. Manually, you're building 2, maybe more explicit contracts. With automation, you define just one logical contract. The end result is a massive shift away from high overhead and complexity to a much simpler intent-based model.
So, why does this matter so much? I mean, in a real-world, fast-paced production environment, what's the tangible benefit of all this automation? Here's the bottom line. Automation leads directly to reliability and simplicity. By automating the creation of all those complex underlying policies, service graphs just slash the chances of you making a manual configuration error. And when something does go wrong and you have to troubleshoot, you can look at the high-level intent instead of digging through a bunch of separate confusing policies. It really fundamentally changes your job from managing network connectivity to managing application policy. It's a huge shift.
So we've seen how service graphs are absolutely brilliant for simplifying policy in these standard insertion scenarios. But what happens when your service device isn't in the direct routing path? What if you need to force traffic to a firewall even when the normal rules of routing say it should go somewhere else? Well, that's where the next evolution of this whole concept, policy-based redirection or PBR, comes into play. And that is a topic for another Explain.